Exercise 1 says the area of the circular pool below can be found by using the formula A equals pi r squared. If we know the area is 234 square feet, find the radius and the diameter of the pool. So using the formula A equals pi r squared, we know that the area is 234 square feet, and we don't know what the radius is. So in order to get r by itself, the first thing we want to do is we want to divide both sides by pi. So 234 divided by pi. I will round it to 4 decimal places. So we get r squared is equal to 74.4845. Okay, and now we have r squared equals, and in order to get r by itself, the next thing we have to do is we have to take the square root of both sides. So that will give us r equals, and I need to take the square root, so I'm going to hit second, the square root button, and then second again, and I'm going to press answer here, down here where the negative sign is, and that just takes the square root of what we solved in the previous calculation. So if I hit enter, then we get that the radius of the pool is 8.6304 feet. So that represents the radius of the pool. The question also wants us to find the diameter of the pool, and diameter is equal to 2 times the radius. And so if we took that number and we multiplied it by 2, we would get 17.2609. So the diameter is equal to 17.2609 feet. And that is how we would find the diameter and the radius of this swimming pool. The prism below is formed from a square side of length 3 centimeters and an unknown side length. The total volume can be found using the formula volume equals length times width times height. If volume is 54 centimeters cubed, find the missing side. So in the problem, we are given that this shape here is a square. So if one of these lengths is 3 centimeters, then this length also has to be 3 centimeters. All of them are 3 centimeters. So the value that we are trying to solve is this value here, and I'm just going to call it h for height. Now we do know the volume, so let's rewrite our formula. We have length times width times height, and we know all of the values except for the height. So the volume is 54, the length is 3, the width is 3, and then we don't know what h is. So let's do some simplification. We have 54 equals 3 times 3, which is 9, h. And now I can divide both sides by 9. So if I divide, then we get h is equal to 54 divided by 9, which tells us that the height is equal to 6 centimeters. Find the value of x first, and then the length of the sides, assuming the perimeter is 200 feet. Now we have a parallelogram here, and the way that you find the perimeter of a parallelogram is just like you would for a rectangle. You would add this length plus this length plus this length plus this length. But before we can find the dimensions of this parallelogram, we need to figure out the value for x. So in this case, the perimeter is equal to 4x plus 4x plus 5 plus 4x plus 4x plus 5. So I basically just rewrote all of the side lengths in that perimeter formula. And we know that the perimeter is equal to 200, so I will replace p with 200 here. Now on the right-hand side of the equation, I can combine some like terms. So 200 is equal to 4x plus 4x plus 4x plus 4x. That should be 16x. And then 5 plus 5 is 10. So now from here, my goal is to try to get x by itself. So I'm going to subtract 10 on both sides. And then that will give us 16x is equal to 190. I just went ahead and I swapped the sides. And from here, I want to divide both sides by 16 to try and get x by itself. So these will divide and we'll get x is equal to 190 over 16, which is equal to 11.875. And so now we want to use that x value to figure out these dimensions. So let's figure out this dimension here first. So 4x is going to equal 47.5 feet. And then the top dimension and the bottom dimension are equal to 4x plus 5. So now I'm just going to add 5 to that, and we get 52.5. So this here is equal to 52.5 feet. So I'm going to box my final answers. And that concludes exercise 3. Exercise 4 says, above is a duck pond with an island in the middle. The water ring has diameter 200 feet. Find the area representing the water ring and the area for the island if the island has a diameter 100 feet. Use algebra and show your steps in a logical manner. So let's kind of draw this out. We know that the water ring has a diameter of 200 feet. That means from one end of the circle to the opposite end, that length is 200 feet. So we are more concerned about the radius if we're talking about circles. And so if that length from here to here is 200 feet, then we know that the radius is equal to half of the diameter. So if I started at the center here, and we were concerned with that length there, which again is called the radius, we know that that would be half of 200 feet, so that's going to be 100 feet long. And then we know that the diameter of the grassy area is 100 feet. So this length here is 100 feet, but we are concerned with the radius of the grassy area. So if I measured from the center to the edge of that, we know that that is going to be 50 feet. Okay. So our goal is to try to find the area of the water ring. And the way that we're going to do that is we're going to calculate the area of the bigger circle and subtract off the area of the green circle. So let's calculate the area of the big circle. So area equals pi r squared. And we know the radius is 100. And so if we square 100, we get 10,000 pi. So that is the area of the bigger circle. And then if we're calculating the area of the grassy patch, we get area equals pi r squared, which the radius in this case is 50. And so 50 times 50 is 2,500 pi. So the area of the whole big circle is 10,000 pi, and then the area of the green circle is 2,500 pi. And our goal is to figure out the area of just the water region. So I'm shading it here in red. So our goal is to find the area of the red region now. And the way that we're going to do that is so I'm calling it the red area, or the water ring, is going to be the area of the big circle minus the area of the grassy patch, which is equal to 10,000 pi minus 2,500 pi, which simplifies to 7,500 pi. And if we throw that into our calculator, we get 23,561.94. I'm just going to round it to the nearest whole number. So 23,562 square feet. So that is the area of the water ring.